this video, we're going to be going over testing the correlation coefficient for a statistically significant correlation. So we're going to be using this formula here, R-test, and this test follows the t-distribution with n-2 degrees of freedom. So the t-distribution is basically a set of data tables like this, and it allows you to basically compare the value against our R-test value to test whether it's statistically significant or not. So I'll show you how to use this in the examples. So test whether the following correlations are significant. So we get a correlation coefficient of 0.998 and n equals 6. N is the number of data pairs you could say we have. It's a two-tailed test at 5% significance. So with two-tailed tests, you have to divide the significance by 2, right? Schematically, it's checking both sides of the distribution, which is why you have to divide it by 2. So it will be 2.5% either side. So we have a two-tailed test, as we've mentioned before. That's important to remember when we look at the tables. But right now we need to calculate our R-test value. So we have R-test equals 0.998 multiplied by 6 minus 2 over 1 minus R squared, 0.998 squared. That gives us a value of 0.998 multiplied by 6 minus 2, that's rooted, and root 1 minus, that gives us a value of 31.57. Now when we compare with the t-distribution, so it says we have n-2 degrees of freedom, we have a 2.5 significance on either side because it's two-tailed, and our value was 31.57. So because we had a 5% significance level, but it was two-tailed, remember we halved the significance level by 2, so technically 2.5%. So because we're looking at it from the left-hand side, you could say, of the normal distribution, the 2.5% correlates to a 0.75 area, right? If I were to draw here, so 2.5%, so this area is 0.975, which is why we look at this column for our data. We had 6 values because our n value was 6, and to find the degree of freedom, i.e. the number on this side to look across from, we had to minus it by 2. So degrees of freedom was 6 minus 2, which is 4. We look at 4 and this column, so our t value is 2.776. So if I write that down, t is 2.776. Now we compare that to our R-test value. Now here, it's very obvious that 31.57 is larger than 2.776. And what this means when our R-test value is larger than the t value, it means our correlation was significant. So we can say that. It's also quite obvious by the R value that we were given. So an R value close to 1 or -1 is very, very strong, either in the positive or negative direction, and this value is close to 1. So even without the test, it would be a good guess to say that this is a strong correlation or a significant correlation, but this test just proves that. So if we do another example, we have R equals 0.365, n equals 9, and it's a two-tailed test with 5% significance again. So we're looking in the same column on the t-distribution, but maybe not the same row. So we're going to do our r-test again. So we have 0.365 root 9 minus 2. As we can see, 0.365 isn't the strongest correlation, and it's moderately weak actually, because it's closer to 0 than it is to 1, but we can test using this to determine if it's statistically significant given the dataset values we have. And so if we carry on with this calculation, 1 minus 0.365 squared, we get 0.365 multiplied by root 9 minus 2 root 1 minus 0.365 squared. That gives us a value of 1.037. So we need a t value again. So if we look here, our value of n was 9. So to find the degree of freedom, it's 9 minus 2, which is 7. And it was still the same as the last example, as in the 5% significance two-tailed test. So we're still in this column. If we find our value, we have 2.365, which I'll write down. So t was 2.365. As we can see, 1.037 is less than 2.365. That means that an R value of this, given the data, shows there's no significant correlation. So we'll put no significant correlation. Not statistically significant according to the test, the significance. So that's how you would tell if it's significant or not significant, depending on the t value. And this t value could change depending on how many degrees of freedom you have and the percent significance. So if we do one more example, we have an R value of 0.465, n equals 17, and it's a two-tailed test at 10% significance. So because it's 10% significance, we're going to be looking at a different column than the ones we've looked at before. So we're going to do an r-test again, using the formula at the top of the page. We have 0.465 multiplied by root 17 minus 2, and that's all over 1 minus 0.465 squared. If we do the calculation, we get 2.034. Now if we look at our table, we have a value of n, that's 17. So 17 minus 2 is 15, and we had a 10% significance level in a two-tailed test. So because it's two-tailed, we half the significance, so 5%, and we find the corresponding area here. So 5% significance leads to a 0.95 area on the left-hand side. So we're looking at this column, and we get a t value of 1.753. So t equals 1.753. So our test value is larger than our t value, so we have a significant correlation. Now this might seem a bit odd, as 0.465 isn't close to 1. However, the value of n is 17. So this test is important to determine if it's significant or not. And that's it.